Hi all, this lecture is on the standard normal distribution, which is a very important lesson since next week's lessons depend directly on this one. So the standard normal distribution is a continuous distribution, which there are a couple of things you need to know about continuous distributions. A continuous random variable has infinitely many possible values. So we cannot list all the values like we did in the discrete distribution. So what we do is give the probabilities in a formula or graph. Since there are so many possible values for the random variable, infinitely many, the probability that the random variable is exactly equal to one particular value is so small that it's actually practically zero. So what we do instead, we find the probability that the random variable is in a particular interval. For example, we find the probability that is between -1 and 1. Okay, so now let's talk about the normal distribution. Why should we study the normal distribution? It's a good fit for real data. A lot of the things in the world follows the normal distribution. It's very easy to interpret with a normal distribution. It also comes up with what we will be getting into later on in this course. So here's the graph of a normal distribution. It follows a bell shape like we discussed in the previous lectures. It is symmetric and it has just one peak, not bimodal. Every normal distribution is described by its mean, which is denoted as mu, and its standard deviation, which is denoted by sigma. U can be any value at all, negative or positive, but sigma can be any value above 0, so any value greater than 0. And now looking at a specific or particular normal distribution, the standard normal. The standard normal is a distribution that has the mean of 0 and a sigma equal to 1, so standard deviation equal to 1. It's also denoted as Z or called Z. If you see Z, they're referring to standard normal distribution. It looks like this graph. So we see that the mean is 0, and we go over one standard deviation. So this is one standard deviation above the mean, and then if we go the other way, it's one standard deviation below the mean. It's 1, right? Standard deviation is equal to 1, just like we said. And then again, we go 2 standard deviations over, it's 2, so 1 plus 1 is 2. That's the standard deviation. The area underneath the normal distribution is 1, and this is the same idea as the discrete probability, that all the probabilities have to sum to 1. The way we find probability for standard normal distribution or any continuous distribution, we look at the area between those two values. It's possible to use Excel to calculate the standard normal probabilities, but I think it's easier to use the Z table in your book, and I'll pull that up right now. So here's the negative side, and then if we go to the next page, we see the positive side. And here, what you're looking at in the left column, it represents the whole numbers and the tenths place, and then at the first row, they represent the hundredths place. So if we were to look for -3, let's do 3 and 3.04, right? So we go 1, 2, 3, 4. We have 0.9988. This is the probability that Z is less than 3.04 right here. So if you were to asked to find the probability that Z is less than 3.04, we would go down to 3.0 and then over, let's just show you the top, over to the 4.04. Okay, now the table is just built where all of the areas are to the left, so I'm going to go to the negatives to show you this too. To the left. So again, all of the areas are to the left. One probability I want to show you is if we were to look at when z is less than 0, we would look right here and here, when we see that the probability is equal to 0.5, which is half, and we know that the mean of the standard normal distribution is 0, so this makes sense because the mean is in the middle of the graph. So back to the thing. Okay, so the z-table. I just want to be very clear on what the numbers are that we are looking at. So again, back to the table. I shouldn't have left, but so the values on top and the side are the z's, and the values in the middle are the probabilities. So the z values are the values that are on the bottom of the curve. So going at the top, sorry. The z values are the values that are on the bottom of the curve, and the area, the values that are in the middle of the plot, are the area which is in the middle of the plot as well. Okay. So there are really just 3 different scenarios for these kind of problems. And if you can understand all of these, then you can do any problem. The scenarios are less than, greater than, and the between case. Let's look at each of these now individually. So here's the less than scenario. Suppose we wanted to find the probability that z is less than 1.27. So here's a picture of the z-table. But if we go back to the book, let's see, and we're on the positive side, and we go down to look for 1.2 right here, and then over to 0.07, right, which is right here, we find that the probability is 0.8980. So that's the probability that z is less than 1.27. So in other words, if we pick a random value off the standard normal distribution, there's a 89.8% chance that z will be below 1.27. And here is the illustration of that example. And we know that 1.27, it's more than half because 1.27 is bigger, greater than 0. So now looking at the greater than scenario. Suppose I wanted to find the probability that z is greater than negative 2.83. So here's the picture. We see that 0 is in the middle and negative 2.83 is right. We are looking for the area to the right of negative 2.83, so right here. If we look up negative 2.83 in the book, that value is 0.0023. We can just do that real quick. So we go to the negative side. Negative 2.8, we said right here, and then 3. There's our answer. But that's not the answer. So the fact that the area underneath this curve is equal to 1 comes in play. Now subtract the value we just got at the table, which is 0.0023, by 1, and we get 0.997, just like the plot says, 0.9977. Now the between scenario, which may be the toughest scenario, but it's doable. Suppose we want to find the probability that z is between negative 0.75 and 1.20. Here's the notation, and here's the graph where the area between is shaded in. So the next slide will clear things up on how to calculate this then. Okay, so the first thing we want to do is we want to find the area to the left, and because the table is set up with the area to the left. So we first want to find the probability that z is less than 1.20, which is this graph. And if we looked at the table, it's going to be 0.8849, the probability. But we also have to keep in mind that there's this small area right here, that is the probability that z is less than negative 0.75. We need to subtract that in order to get this middle section. So we look at the table and we find the probability that z is less than negative 0.75, and we find that the probability is 0.2266. So now all we have to do is take this value and subtract them. So 0.8849 minus 0.2266 equals 0.6583, and we get the between. So not too bad. Okay, I'm going to start here on part 2 of this lecture. Again, I'm running out of time since these lectures have to be short, so stay tuned.